Welcome back. This is an Aleks training video on interconverting the wavelength and frequency of electromagnetic radiation. The speed of light and the speed of all electromagnetic radiation is the same. It goes by the symbol c. So like E equals mc squared, that's the speed of light. So the speed of radio waves is the same as the speed of light. The speed of gamma rays is the same as the speed of light. And it's going to be equal to how long the wave is times how frequently that it passes. So let's imagine a train passing you, and the cars are a certain length and they're passing you at a certain frequency, say one car every second. Then you can say that whatever length times whatever frequency equals the speed. So the speed of light in this case is equal to the wavelength of light, how much distance it covers, and then how frequently that distance passes you. Okay, so C equals lambda nu. Well, they're going to see that this is going to be a constant. It's always the same. It's 3 times 10 to the 8 meters per second. Aleks is really particular, and like if you were to press the data or the calculator button on that, you can pull up those things and it'll actually just put it into your calculator. I think they're using the long one. So the speed of light is 299,792,458 meters per second. I would never make you learn that. I don't even know it. 3 times 10 to the 8, you see everything simply rounds up to 3, and then 10 to the 8 meters per second. But I think you need this in order to get it right. So if this is C, they're going to give you one and ask for the other. So they're going to give you the frequency of 548 megahertz. Okay, so we need it to be in hertz because it's going to be in meters per second, and hertz. Okay, hertz is something divided by seconds, so then your speed will be in meters per second. So I need to take 548, and which is megahertz, and mega means million. Okay, so that's 10 to the 6 hertz. Okay, 10 to the 6 is a million. And so it'll be 548 times 10 to the 6. If you're going to do it in scientific notation, it would have to be 5.48, and then this 6 would go up to 7, 8. So 5.48 times 10 to the 8. So let's put it in, and you're asked to find the wavelength. Okay, so let's solve for wavelength. Let's get nu by itself, or lambda by itself, that's wavelength. So it's going to be speed of light divided by nu. So lambda is equal to the speed of light divided by nu. That's going to be 299,792,458 meters per second divided by 5.48 times 10 to the 8. Which is seconds to the minus 1, so these two will cancel. And then you'll end up with meters. Seconds and seconds cancel, and your wavelength is in meters. Okay. All right, so you get lambda equals 0.54706 ... it goes on, meters. Now I need significant figures. I've got 3 here, so I need to do 3. So it's going to be 0.547 meters. Okay. Okay, so let me do it one more time. 9.79245 divided by 5.48 times 10 to the 8. Okay, 0.54. If I'm going to have 0.54 meters, that's like a half a meter. Most likely they're going to do it in millimeters here, so that it's like not a decimal for everything. Usually they don't mind a decimal, but they don't want everything to be in a decimal. So probably it would either be in centimeters or millimeters. So let's do millimeters. This would be 547 millimeters. Okay. All right, thanks.